Good morning, everyone. I'm Don Marty from Mozilla Open Innovation, and I'm happy to introduce Professor Arvind Narayanan from Princeton University. He does research on information security and privacy, including the Web Transparency and Accountability Project, which tracks a lot of tracking and data usage practices on websites in the wild. He also works on using big data to infer sensitive information from anonymized records. Please welcome Professor Narayanan.
All right, thank you, Don. Delighted to be here. This is my first time here, but I used to visit 650 Castro a lot many years ago when I was a postdoc at Stanford. So very happy to be back. I think we're here today because of a shared understanding that online tracking and advertising have gradually gotten more intrusive over really the last 20 years, but things have perhaps come to a head now. And there seems to be an increasing consensus that browser vendors have a role here, and browsers need to step up to protect users. So the question is, what is that role? What is that responsibility? How best can we protect users from intrusive tracking? And what I want to share with you today is based on research that I've done with Princeton, really led by Steve Engelhardt, who is here now as of a few months ago, and Ganesh Achar, who's a postdoc at Princeton, and many other collaborators. Now, and I'll structure this as a series of suggestions. Some of these suggestions, when you hear them, you're going to say, oh, we've already been doing that for a year. And that's great. I fully expect that, and I would be happy to hear that response. Some of these suggestions, on the other hand, you're going to go, oh, that's never going to fly. That's not the role for a browser vendor. And that is the reaction that I'm going for. So I do want to sort of put things on the table that I think are not necessarily realistic today, but would be good to think about over the next 10-year time frame. Because if we look at where we were 10 years ago, the conversations that we're having today about blocking third-party trackers, for example, were not conversations that we were having at that time, and things have changed. So I want to look forward to what are going to be the upcoming challenges, responsibilities for browsers for the next 10 years. So that's going to be the theme of my comments, and I'll structure this in 4 parts. One, I'll keep part number 1 short, but I think it's good to talk a little bit just recapping exactly how bad online tracking has gotten, and I will emphasize some of the research findings that we've had over the last 6 months or so that might be somewhat new to many of you. And just appreciate the sheer creativity of some of these recent tracking techniques that we've found in the wild. And then I want to talk a little bit about what are the root causes of the problem. And what I mean by that is I'm going to give you 2 reasons. One is a technical reason and the other is a non-technical reason, due to which I believe we don't have a really principled rigorous computer security way of tackling this problem, and also why we haven't addressed this problem for so long, why it's come to a head today, so to speak. And I think that a little bit of background is necessary to then go on to talk about what are the possible responses. What can Mozilla do today, but also more broadly, what can browser vendors do over the long term, over the next 10 years? What are the new things that we should be thinking about beyond even tracking and advertising? So I'll structure it this way. So let's get started. Let me briefly tell you how we got started on this research topic. The first major thing that we found in our research was that canvas fingerprinting was going on thousands of sites. This was back in 2014 when people really had no suspicion that this was being deployed in the wild at all to track users. So just as a super quick recap, what is canvas fingerprinting? On this diagram, you see a piece of JavaScript, typically third-party JavaScript, using various commands that are part of the Canvas API in order to draw that picture on the screen and then read it back as a sequence of bits. The idea here is that based on tiny system differences between browser versions, between graphics libraries, operating system differences, the exact sequence of bits that you read back for the same set of commands is going to differ from device to device. And so the hash that you retrieve is going to act as a device identifier, which is sort of a proxy for a user identifier. And the reason that this has become very popular with tracking and advertising companies is that it's more sticky than a cookie. It doesn't go away when you clear your cookies. Now, the thing that really surprised us here, though, was we said to ourselves, imagine how different all this would have been if there were, for example, a browser extension to reveal these invisible images that are being drawn on the user's screen. And typical users were encountering this dozens of times per day. And it would have been completely and utterly obvious, and people would have been totally creeped out by it. However, because we didn't have anything structural in place to go and systematically find the different tracking and fingerprinting techniques that were being deployed, nobody caught on to it, had any suspicion of it until it was so widespread that it was being deployed on 5,500 at least of the top 100,000 sites that we looked at. So that was the starting point for us. We realized that there was some gap, and we summarized this and many other research findings in this paper back in 2014. But once we did the study, we realized that there's a need for this kind of research, and that led us to ask, what if this kind of oversight of online tracking could be automated? Instead of waiting to hear about a particular privacy violation and then spending a lot of person hours looking into that, what if we could scale it up, do it on a large scale, and have a single infrastructure that could look for a variety of different privacy problems and even figure out new privacy problems that had not been suspected? So that's why we built, and when I say we, I mean Steve is really the lead developer of OpenWPM, which stands for Open Web Privacy Measurement. Today it's become a pretty mature open source tool. You can see it's pretty active on GitHub. And many other researchers, not just our research group, has been using it. It's been used as the basis of about 20 to 25 different privacy studies now. And I'll come back to OpenWPM in a second, but I want to give you a quick taste of some of the things we've found using OpenWPM. One of the things that we found is that anytime a new API gets into the HTML standard, tracking companies figure out really creative ways of misusing these APIs for fingerprinting purposes. For example, the audio, battery, and WebRTC APIs. Some of these really surprised us. When we found the battery API, for example, being used for fingerprinting, we didn't at first understand why that was happening. And when I asked students in my classes, why do you think the battery API was used for fingerprinting? The responses that I get are along the lines of, oh, maybe the rate at which your battery drains is something that really identifies your device, etc. And those are reasonable guesses. Those could be reasons to use the battery API for fingerprinting. But that's actually not primarily why it was being used. It was being used for the following reason. Even though it's not necessarily a stable identifier from time to time, even though your battery level and the rate of battery discharge might change this month to next month, it was being used as an instantaneous fingerprinting mechanism to link two simultaneous sessions by the same user. Imagine that I'm visiting CNN.com and I'm not worried about my privacy looking at CNN.com, so I browse CNN regularly in Firefox. However, I'm also simultaneously visiting some other sites where I do care about my privacy, so I route that through a VPN. What can happen is if the same third-party tracker is embedded on both of these sites, by looking at the instantaneous battery level and the rate of battery discharge, those two sessions at the same instant in time can be linked to each other. And so we hadn't anticipated this at all. We didn't realize that people were starting to do this until we did these studies and analyzed the scripts that were actually doing this in the wild. So very quick progress in fingerprinting techniques. This is audio fingerprinting, for example. So what's happening here is that the audio libraries are being initialized and a fast Fourier transform is computed. And it turns out that because of lossy compression and things like that, the exact amplitude response that you get out of the FFT at different frequencies is an identifier for the software stack that you have that computes that transformation. So even between two closely related versions of Firefox, you see that you get a different fingerprint. So this has been advancing very rapidly, and I'm sure that this is old news to many of you. And let me tell you about some of the things we've been finding over the last 6 months or so. And this is more to do with the exfiltration of personal information, actual user identifiers, as well as a variety of other sensitive private information that users share with the websites that they visit being exfiltrated by third-party companies. So how is this happening? Why is this happening? Let me give you an example. Let me start with session replay scripts. I'm sure this is familiar to many of you. So this is how session replay works. On the left, you see a user browsing a site. And what's happening on this site is there is a third party, which is a session replay script, which tracks everything that the user is doing over here and then stores it in a database for the publisher to later look at for analytics purposes, for finding bugs on their site, for finding points in their user interaction flow, perhaps where users are dropping off. So let me just give you a quick demo of what this might look like. On the left, you see the user typing, and this is just a test setup, so it's localhost. And they've put in a variety of sensitive information. What's happening here is that's all being captured by the third party. And then when the publisher later logs in over there, they can actually see the user session in real time, just with about a 1-second delay. So this is pretty common on the web today. This is the idea of session replay. Now, as you can imagine, in the process of capturing user activities, what is also being captured is all of the sensitive information that's either displayed on the page or is input by the user into a form. Okay, so we looked at session replay scripts, and what we found, perhaps unsurprisingly, given that we've seen how it works, is that this process involves the rampant exfiltration of personal information. And this includes passwords and medical information, and even if the form was never submitted, anything that you type into a form in real time is being captured and stored on these third-party servers. So we confirmed that this is happening on about 8,000 sites. And what I mean by this is we used our automated measurement platform to inject personal information into these sites and confirm that when we do so, it's being sent to third-party servers. Whether there are actually forms on those pages that include medical information, et cetera, that is not something we can do in an automated fashion. But to the extent that we've been looking at this manually, it does seem like there's a huge number of sites that are affected where actual sensitive information is being exfiltrated in this form. And that includes HIPAA-protected information and FERPA-protected information. Funnily enough, we found that this was happening on our own information security course website for student grades and professor comments and all kinds of other protected information because of the site that we used as Gradescope, and they were using one of these session replay third parties that was grabbing all of this information. I mean, when I imagine the amount of manual time and effort that it would take to identify every one of these publishers that are affected and inform them and educate them about what is going on and what they can do to protect themselves from third-party personal data exfiltration, I don't know that that process is ever going to happen. We're not the wants to do that. It doesn't constitute in research. So this is as far as we can go using these automated methods to quantify the extent of the problem. The actual cleanup, so to speak, I have to use an analogy here with the sort of environmental causes, really. I think we're going to be feeling the effects of this kind of thing for decades, and we're gradually going to be identifying new privacy problems because of this rampant leakage of personal information. And to be honest, I think it's just genuinely different to grow up in a society where you have the knowledge that the most intimate information that you put on the web is residing in dozens, perhaps hundreds of third-party servers with no transparency or accountability and no real knowledge of where that information is further being sold or transferred, et cetera. So that's why, even though we were kind of jaded coming into this research project, we thought we'd seen it all. This was still kind of a new level of shocking for us. And then we kept finding new types of leakages that we had not anticipated before. We found exfiltration of usernames and passwords. This one is really sneaky because the third-party script actually injects a login form where there is none, waits for the browser to autofill it, and then exfiltrates the username. And exfiltration of passwords is also going on. This, fortunately, is accidental. Scripts are not actually trying to do this. However, in the process of grabbing various other things on the page, it turns out to be an essentially technically impossible problem to make sure that you're never grabbing passwords because of complex interactions between the first-party script, third-party scripts, and browser extensions that the user might have installed, such as a show password browser extension that's going to change the type of input fields from input type equals password to input type equals text. And so all of the combinations that can occur because of these interactions is not something that can really be tested. And the current approach of creating manual blacklists for patterns that you don't want to exfiltrate is really not scaling up to all of the complexities that we've found when you look at 100,000 sites or 1 million sites at once. So this was happening pretty frequently as well. One other category that we found is when users use Facebook login to log into websites. What happens here, this is a bit of an oversimplification. When they use Facebook login, the first party is going to cache the Facebook auth token that they need for interacting with Facebook in the future. However, third-party scripts are just dropped into the page in a first-party context, and I'll have a little bit more to say about that. But when that's happening, there's nothing preventing the third-party script from actually accessing that auth token, essentially pretending to be the first party, and then querying Facebook and grabbing the user's Facebook data. So we found that this is happening as well. So I've given you a small taste of this. We have actually a very detailed series of blog posts where there's a lot more going on, and I encourage you to look this up if you're interested. You can just search for No Boundaries Princeton, and our series of blog posts will come up. So this is what we've been doing over the last 6 months or so, and we have one more post along these lines coming up. And note that all of these are new categories of privacy problems. It's not just that we quantified something that had been known before, but nobody has suspected that this sort of thing was happening at all. And we were able to find these because of running these large-scale crawls. So that brings me to my first suggestion. The reason that we've been able to do this, even though a lot of research groups have been interested in going after these privacy problems, is it's not just that Stephen and Ganesh were smarter than all the other researchers. It's true, they're very, very smart. But I think the key advantage that we had is that we put years of person effort into building this instrumented browser crawling infrastructure. And we have data from 1 million websites every month, and we have interactions of simulated users, and we have all of the network logs that result from those interactions and so on. So when we have data at that scale, it becomes really relatively easy to find these privacy problems. So the thing that really worries me is that now that Stephen has graduated and Ganesh, my postdoc, is going to be around for a little bit longer, but after that, we're not going to be running these crawls. So the question is there somebody who's going to be running equivalent crawls? And I want to say that whether it's us or somebody else running these kinds of large-scale crawls with instrumented browsers, I want to say is really essential to the health of the web. Because without it, we don't really have good ways of finding these problems. Even when people have suspected these kinds of problems before that I've just discussed, even when journalists have gone after that, they were able to find maybe one site where this was happening using manual analysis, no way to quantify the extent of the problem, the seriousness of the problem, the complexity of the problem. So I really hope that perhaps this can happen at Mozilla, and I know that conversations are actually already happening here. And I think it would be wonderful if there can be some sort of either a collaborative setup or just Mozilla taking the lead in systematically running these large-scale instrumented crawls of the web. So that's my first suggestion. And with that, I want to move on to taking a step back and talking about what are the root causes of the problem. How did we get into this state? How does the fundamental security model of the web even allow these types of problems to happen? And second, knowing that these problems do exist, how did it take so long for us to start addressing this problem as a community? So let's talk about that. And here, this is just my personal view on what is happening here. I would love to hear your comments, feedback. Feel free to interrupt me, and I'm also going to be sticking around today until 2 p.m., and I would love to have chats about exactly what went wrong here, what can we learn from this, and what can we do better in the future. But to me, the key diagnosis, so there's one technical reason and one non-technical reason. I think the technical reason is that we're missing a feature that has proved to be really important for the mashup model of the web, which is that we really need ways to enforce boundaries within the DOM. Publishers, first parties, really want to be able to say to third parties, you're allowed to look at these parts of the page, but not these other parts where there is sensitive information. And they want to be able to do that in a way that is both secure. There are no unanticipated leakages between one part of the DOM and another part of the DOM, and also really convenient. This is something that somebody should be able to, who's not necessarily a security expert, should be able to code up and have it work securely and reliably. We don't have that today. The security model of the web, of course, relies on the same origin policy. It's good for what it is, but it's a very blunt and crude baseline. And the same origin policy doesn't allow this kind of granularity. The same origin policy gives you two choices. One is you can completely isolate the third party within an iframe. And this is, it doesn't give publishers and third parties the functionality that they want to actually interact with the page. And so it ends up being rarely used, which is somewhat disappointing and unfortunate, I think, of how many ad scripts are directly embedded into pages. And so that's the latter option. And so if you load these third-party scripts directly in the first-party context, then there are no security boundaries. You don't get to enforce any security properties at all. And the script is it's going to be free to basically run around the page and look at any data that it wants. So this is the situation that we're left with today. And of course, researchers and browser engineers have long recognized this problem. I'm not trying to say anything new here on this slide. And actually, in response to this, there's been a huge amount of research about how can you bring this kind of boundaries or sandboxing into the picture. And just to give you a visual taste of just how much of this research there has been, I want to point you to one survey paper. I thought this was a really nice paper, which is about 80 pages long and has 99 references just on different techniques for sandboxing JavaScript, right? So that's how much of a hot research problem this has been. Everybody has recognized this as a problem. So many people have proposed solutions for trying to solve this problem and introducing effective sandboxing to the web. And the question that I want to ask is, why has this not happened, right? And then this paper, I just want to briefly mention, surveyed so many different techniques, so many different categories of techniques. There are techniques based on rewriting JavaScript. There are techniques based on browser modifications to effectively enforce the sandboxing. And there are techniques that require actually no browser modifications. And I think generally, the way I understand it, the techniques in the last category work based on the publisher JavaScript loading first and then creating some wrappers around various JavaScript objects in such a way that when the third-party JavaScript later loads and tries to interact with those objects, there is kind of a reference monitor, if you will, but completely in user space and is able to interpose between those queries to those objects and make sure that the third-party JavaScript stays within its sandbox. I don't know if that describes everything in the third category, but at least some of those techniques. And so there's been a lot of energy in this space. And especially, for some reason, this was really popular up until 2013 or so. And after that, many of these efforts started dying off. And this has been a curious phenomenon to me, and I don't understand why this happened. My guess is that it's a combination of technical reasons and non-technical reasons. Google Kaha, for example, was one of the more prominent of these projects. This is Kaha's GitHub, and you can see around 2013, 2014, there's a very sharp drop-off in activity. And I would love to learn the story, talking to people who were involved in this of exactly what happened here and why, not just with Kaha, but with a number of these other projects, there was kind of a sudden drop-off in interest in the 2013 to 2014 timeframe. And I think it would be good to learn lessons from this. And the reason for that is because I think these efforts are once again kind of starting up. I've been hearing a lot about frozen realms, for example. This is a proposed addition to the ECMAScript standard. Now, I won't at all pretend to understand this well, but I'm just going to channel what's happening in frozen realms in a 30-second slide, just to give you a sense if you haven't seen this. So frozen realms is a way to create new realms, which are basically these JavaScript object graphs. And so what you see in this picture so far sounds similar to iframes. So the parent realm has created two child realms and possesses references to both of those. So what's new here, what's happening that's different compared to iframes, again, my understanding, not at all an expert on this, but just based on reading the documentation, is that what's new here is that these realms are lightweight immutable copies. This is not a whole new object graph that's created from scratch. It's an immutable copy of the parent graph. And it's lightweight in the sense that I think creating and modifying these doesn't take as much effort as duplicating the whole object structure. So that's one advantage. And also it allows some amount of explicit shadowing, is I think the term that I've seen in some of those documents, between the parent and the child realms. So my understanding is that there is a way to say you can look at this part of the DOM and the changes that are made on the page are going to be reflected to the third-party JavaScript, but that doesn't extend to the entirety of the page. So to some degree, this can address some of the problems, I think, that are the root causes of what we see going on with online tracking. So I think this is awesome. Again, I don't have the specific knowledge of frozen realms to have an opinion of whether this particular proposal is our best shot, but I think these sandboxing efforts are important and they should go forward. I do want to point out some caveats for relying on sandboxing really to address third-party tracking. One is that proposals like frozen realms are addressing a slightly different problem from third-party tracking, which is more about the integrity of the content rather than the confidentiality of the content and the potential for third-party tracking. So there's a slight mismatch there. And Frozen Realms itself is a pretty low-level proposal. To be able to use that to get to a point where you can get effective, usable sandboxing that publishers can use with the ad tech that they deploy will require a lot of development of extra libraries and new layers to go on top of this Realms proposal. And of course, that sort of thing will take years to happen. And we kind of don't have the luxury of waiting that long. And also, perhaps most importantly, the non-technical problem here with relying on sandboxing to protect against third-party tracking is that it just puts the onus on the publisher. It says to the publisher, you have to use this technology now and to really figure out for each piece of third-party JavaScript on your site what it's allowed to do and what it's not allowed to do. And you have to draw those sandboxes and define them precisely. And that really doesn't work with the model of the web today, because the reason that these third-party mashups are so popular in the first place is that the deal that analytics companies and others offer to publishers, to first parties, is, look, just drag and drop this one line of JavaScript into your page, and so we'll take care of the rest, right? So that's the model that's made all of this so popular, and these proposals don't work within that existing model. It's going to push a lot of the burden to the first parties. Now, even given all of those caveats, I think some kind of sandboxing model is really important for the future health and security of the web, and so that leads to my second suggestion. I think browsers should really get behind this. Again, I'm not taking a particular stance on frozen realms or if it's something else. Cowl is something that I've been hearing about as well, and even content security policy, which Mozilla has been very active in that, has a positive impact, I think, on some types of third-party tracking threats. So it's been good to see that proposal develop over the last few years. Okay, so just wrapping up a little bit on what I think are the root causes of the problem, I think there's also been a non-technical reason why we've ignored this for so long, and which is that the sense generally has been, this is an issue for browser extensions to handle. Right? So the first answer would have been, this is between publishers and these third-party trackers. Browsers don't want to get involved in this equation, and even if a publisher is not adequately sandboxing the third party and addressing the problem, it's up to the user to go install one of these browser extensions. And look, I have nothing bad to say about these extensions. I use them, it's great. However, the key thing I want to emphasize is that this extension-based approach is never going to be the solution for the mainstream user. It requires too much tech savvy, it breaks too much, and so you're always going to be stuck at somewhere between 1% and 5% adoption, best case scenario. And the reason I think that really matters is that browser extensions as a privacy solution are maybe okay if you're viewing privacy as an individual problem. An individual's privacy is compromised, it harms that person. If they want to defend themselves, it's up to them to go and install these browser extensions. But so what I've been going around saying over the last couple of years, and I think there's been a lot of interest in this alternative viewpoint, is that we should really look at poor privacy as a problem for democracy. It's not so much a problem for individuals. It's perhaps very rational for a given user to not care so much about their privacy because it harms not only them, but really poor privacy harms society as a whole. To me, the real question is, are we sleepwalking into a surveillance society? What are the implications for democracy in a society where a few dozens of companies have these surveillance databases that can be massively misused for all kinds of purposes? Another view that a lot of people have had about third-party tracking is that we wanted to protect users without upsetting the apple cart, without affecting the business model of the web. We want to do this in such a way that we make sure we're not pushing too hard against the ad tech ecosystem. Of course, it's a very powerful lobbying system that they've got. So one thing I want to say here is that there is an inherent tension here. I think that's a good thing to strive for, but we should also recognize that to some degree, the business model of today's ad tech is the privacy violation. And so if we want to really protect user privacy, there's going to have to be a little bit of give here. Something's got to change. It's not going to happen within the structure of the existing status quo. So those are some provocative points that I want to put up. Oh, actually, I have one more provocative point, sorry. And this is that I've heard, not so much recently, but maybe a few years ago, that browser vendors want to be quote-unquote neutral on third-party tracking and sort of leave this up to users. And I want to suggest that browser vendors being neutral on third-party tracking is a little bit like email providers being neutral on spam. This would have maybe worked when you saw an email provider as simply a mail transfer agent and the user side of it being completely up to the user. But now we've moved to a model of these centralized email providers where users expect all kinds of services bundled for them, including, of course, spam blocking. And that's one of the primary things users look for in an email provider. I think the same thing is happening with a web browser. People, of course, don't see it purely as a technical user agent, but also expect all of these additional things from the browser, including privacy protection. Okay, so let's get to what can Mozilla do today. And here I'm going to give you 3 suggestions that I think would be great to immediately execute on. And I know you're going to say for some of these that this is already happening, and I would be delighted to hear that. So the first suggestion that I have is, okay, so let me take a step back. So let's think about some particularly intrusive forms of tracking. So I would say that there should not be third-party scripts on any page containing a login form because the passwords and other credentials are at risk there. And what I want to know as a user is, does my browser vendor agree with this point of view? And I want to know, for various other types of particularly intrusive tracking, what is the stance that Mozilla has, that Firefox has? And so that leads to my first suggestion, which is that it would be great for each browser vendor to publish clear policies on what types of tracking are considered acceptable and unacceptable. And I want to emphasize here that I'm not talking about a machine enforceable policy, because the level at which these policies will have to be written, I think inevitably, at least at the present time, makes them not at a point where they're automatically enforceable. However, this should be at a level where a human expert looking at these policies can unambiguously decide if a particular third party in a particular context is violating the policy or not. And here's why I think this would be an awesome thing to have. If we had these policies, that would be specific enough for people to go and construct these filter lists, like Easy Privacy, for example. But a filter list that says, here are the 10,000 regexes that represent all of the third-party patterns on the web that violate Firefox's tracking policy. Right? You couldn't automatically build that list, but human experts could and will build that list. And here are the other awesome things that could happen if this policy existed. People will go and conduct measurement studies. I and other academics would have a huge incentive to take that tracking policy and look at studies and document what are the rates of violation of this policy. And then what we would all be able to do is to warn publishers and third parties that you're in violation of this policy, and so you're in danger of being blocked perhaps sometime in the future. So let me stop at that point, because that's going to lead to my next suggestion, which is the idea of progressive deprecation. So to explain what I mean by progressive deprecation, let me take a step back. When Firefox and Chrome, and I think other browsers, announced that they were going to view HTTP as insecure, when this was announced, that was still 3 or 4 years out, I was shocked. I thought that was incredibly ambitious. It was never going to work. People are going to complain that it's going to break the web. I thought it would never happen. But I think the reason that you guys accomplished that, and I think today we're on track to soon being in a state where plain HTTP will be considered insecure, is because of progressive deprecation. And I saw how well that was executed, and I was really, really impressed. So there was first a very clear, widely publicized announcement that eventually HTTP would be considered insecure, and there was a concrete timeline for the various stages in which this was going to happen, and the screws were tightened gradually, right, on websites who were not complying. There were various kinds of incentives that were employed, including Google doing things like demoting them in the search results and so on and so forth. And that really, I think, provided the incentive for a lot of sites to change their behavior. And I think such an approach could be very effective for online tracking as well. And it would get us away from the dilemma where somebody says, oh, this type of tracking has to be blocked, and somebody else says, oh, but it's going to cause this collateral damage and some legitimate sites will break. And then, today, typically, that's the end of the conversation. But I want to suggest that progressive deprecation is a way to get us beyond that dilemma. So to be a little bit more concrete, here's how I imagine progressive deprecation working. And again, this is something I learned by observing Firefox and Chrome and other browsers. I think the first thing that needs to happen is, as I was saying a minute ago, is to clearly specify a tracking policy. What's considered acceptable and what is not. And the second thing that I think will automatically happen as a consequence of a tracking policy is measurement studies and filter lists that reflect a particular tracking policy. Once we have this, once we have large-scale data on how the web is or is not complying with a particular tracking policy, we're able to do two very powerful things. One is we can start blocking in various privacy-centric modes. The obvious example is private browsing mode. However, I think another powerful avenue is, from what I understand, Firefox and other browsers have a variety of different products, depending on the platform, depending on how the browser is pitched, that appeal to various subsets or segments of users, some of which are aimed at privacy-centric users. And I think those users have a much higher tolerance for some websites breaking in exchange for privacy features compared to the users of vanilla Firefox. And that gives us a powerful opportunity to start blocking some of these sites for these privacy-centric modes, thereby gradually turning the screws, so to speak, to get third-party trackers to comply with these acceptable tracking policies. The other thing we can start doing is putting URL bar warnings, and this is really cool that this is happening for HTTPS. This is an example of what already happens today with HTTPS, and I think there's been evidence showing that publishers react really strongly to URL bar warnings that their site is insecure. Again, this is not breaking any site, but it's proved to be an enormous incentive for publishers to employ HTTPS. And finally, perhaps for some types of especially intrusive tracking, we can progress all the way to step 5, which is blocking those third parties by default. And again, this is not something new that I'm saying. This is something that I learned by observing HTTPS. And I think the same formula can be really powerful for online tracking as well. And this is explicitly contrasted a little bit with the ITP approach, intelligent tracking protection, which is certainly great to have as well. But I think the key difference here is that it's not relying fully on automated blocking. However, it's relying on these humans in the loop and having warnings in place and changing the incentives of these third parties to comply instead of getting into a game of whack-a-mole between increasingly intrusive tracking techniques and increasingly sophisticated protection techniques. So one other quick suggestion is to prioritize bug fixes that will help privacy extensions. And what I mean by this is there are a lot of bugs in Bugzilla today that, if fixed, will allow privacy extensions to work better. For example, I forget if this one affects Firefox or if it's other browsers, but allowing extension JavaScript to execute before any page JavaScript or third-party JavaScript. If we don't have that feature, then you lose the ability for extensions to put various kinds of wrappers around JavaScript objects in order to control the behavior of tracking scripts. So that's one example, but I think Stephen Ganesh have compiled a whole bunch of these bugs that would be helpful for privacy extensions, and of course, we're happy to share that. Okay, last 5 minutes, I want to kind of, pie in the sky. This is the part I promised. What would things look like 10 years from now? What are perhaps some long-term strategies for browsers? What are new challenges that are going to become important? And I want to generalize here. Instead of talking specifically about tracking or even ads, I want to say perhaps what all of these are a general instance of is the fact that what's happening today is that the interests of users are getting misaligned with publishers and advertisers. And that's, of course, a very general problem, and we need to work in various ways to realign those incentives. However, the thing I want to say here is, what if, in addition to being a user agent from a technical perspective, the browser were also a user agent from a moral perspective? That is, whenever there is this kind of misalignment of incentives, the browser actually actively intervened with the user interests at stake. So what could happen? What are some ways in which the browser could intervene? And I'm going to give you, I think, 4 examples of this. And all of these are going to be examples of the browser actually parsing it, having some understanding of the semantics of the content that the user is seeing on the page, and using that to intervene in some way. This is, of course, something that doesn't really happen today, but even tracking protection, I want to say, is an example of, it's a little bit of a baby example of this kind of thing. But what if you could get more serious about this, really understand what's happening on the page, see if that's in line with the user interests or not, and if it's not in line with the user interests, intervene in some way. So let's look at a few examples of these. These are going to be familiar ones. You've seen them in various contexts. I want to kind of put them all together. So the first of these is affiliate marketing. The web is full of videos and articles that pretend to be reviews, but there are reviews, but what is not really disclosed to users is that there is a financial relationship between the review creator and the product that is being reviewed. So this is a YouTube video, and if you look in the description, there's going to be an affiliate link, and if the user clicks that and purchases the product, the content creator, the video creator here, is going to get a kickback. And users are generally not aware of this. We studied this in a paper recently. It's actually going to be presented tomorrow at the ConPro conference in San Francisco, Technology and Consumer Protection, if any of you are going to be there. Arvind Narayanan is the main grad student who worked on that. What we found here is that even though the FTC and other regulatory agencies require that these kinds of commercial relationships be disclosed, both on YouTube and Pinterest, less than 10% of such affiliate links are disclosed. And only about, I want to say 2% or so of them use the kind of language that the FTC is actually comfortable with. So these are really low percentages. Okay, I'll come back to affiliate marketing. You might wonder, okay, so what can the browser do here? I will have an answer for that. I'll come back to it in a second. But the second category I want to tell you about is, again, something that's very familiar, native advertising. On Twitter, many other sites, for example, ads or sponsored posts look exactly like regular tweets, regular content. This is becoming really common. On news sites, you even have examples where there's an entire article purporting to be a news article, but it was written and pitched by a company, and there's a small disclosure saying this is a sponsored post. And similarly, there's a small disclosure here saying that it's promoted, but most users, according to user studies, are not aware of this, are not really able to tell the difference. Okay, third example of this kind of deceptive content online, again, something you're very familiar with, is dark patterns. Here's a dark pattern where it's using high-pressure sales tactics to hurry you through a shopping flow here by telling you that a lot of other people are about to buy this item and it's going to go out of stock. There are a huge number of examples of this. I recommend the Twitter account @darkpatterns. That's where I got all of these examples from. Full credit to them. Let's go through a few other examples. This is an example where if you look for one item, one ticket, it's going to say there's one ticket left. If you look for N tickets, it's going to say there are N tickets left. These kinds of tactics are very common on the web today. This is an example where there's a fake hair in the ad on a smartphone, hoping that you will swipe on it to get the hair to disappear, and that will actually be treated as an engagement with the ad. And there are lots of examples of these. And even the New York Times, this is a different kind of dark pattern. If you want to cancel your subscription, you have to get on the phone with someone, and they will tell you why you shouldn't cancel. And this is something that users might not know when they're signing up for the New York Times. They might realize it later. This is Amazon here, which makes you feel really bad about yourself and maybe really silly if you do not want to sign up for the thing they want you to sign up for. Many, many other examples of dark patterns. Oh, this one, TurboTax, the whole interface seems to be full of these. Okay, dark patterns, affiliate marketing, native ads. The question that I want to ask about all of these is, can the browser intervene? Can the browser actually detect this kind of stuff and make the warning or disclosure more prominent? Can it tell the user that they're encountering a dark pattern, or an article that they're reading right now is actually not a news article, it was paid for by a company? Now, at first sight, this might seem, this is a hard problem. How do you parse the content? People can play whack-a-mole with this kind of thing. But actually, it turns out, at least in some cases, based on the studies that we've done, at least as things exist today, many of these categories are quite easy to detect. All of the affiliate links fall into a certain small number of regex patterns, and we've made all of those regex patterns available on GitHub. And so pretty much every affiliate link that a user encounters can be automatically detected, and perhaps you could have a URL bar notification about what is happening when a user clicks on something. That's one example. Similarly, we're looking into dark patterns as well. And I think 5 years from now, 10 years from now, this is going to become a lot easier to detect and intervene. And so should this be something that browsers should start thinking about today? Let me end with one final example along those lines. This is the idea of perceptual ad blocking. We wrote a whole paper about this. Here, we said ads are actually required to be disclosed because of FTC guidelines and as well as advertising industry self-regulatory guidelines. Can we actually look for those disclosure messages to know when something is an ad instead of using these filter lists to know when something is an ad? And looking forward, I think where this line of research could go is, can we use visual features of the content just like humans intuitively know when something is an ad or not? Can we have machine learning and computer vision technologies automatically look at the visual content of the pages you're looking at to know what's an ad, what's deceptive, various other types of categorizations, and how can all of that play into consumer protection? And I think just to leave you with one last thought, I think the reason that this is going to become important is that the web is no longer just a technical medium. The web is used for engineering society. It's being used, to affect elections. It's being used for all of these very consequential purposes. There are these huge interests at stake, and consumer interests are not necessarily aligned with the interests of the publishers and others that they're interacting with. And I want to claim that in this kind of somewhat adversarial situation, the browser is not going to be able to avoid taking a side. There is no neutral. Let me give you one small anecdote about that. And this is from the do not track negotiations, 6 years ago or so. I had a small part in that, and so I got a front row seat to some of the debates that were going on. One of the questions was, would browser vendors be allowed to enable do not track by default for users as a proxy for user preferences? And one of the arguments made against that, a very powerful ad tech company, I won't say which one, but basically it came to the negotiating table and said, whatever you do or don't do, if it turns out that more than 15% of users have do not track enabled, then the standard is dead in the water. We're not going to respect do not track. Right? And so the point that I'm trying to make here is that there is no neutral. There is no neutral way to set defaults. There are very powerful interests at stake that affect how defaults are being set. And so it's not meaningful for the browser to say that we're going to avoid taking sides in these debates because sides are being taken. And so if the browser is representing user interests, then browsers should have a point of view on privacy as well as deceptive content online, as well as many of the things that we've talked about, deceptive ads, et cetera. So that's kind of my 10-year wish for where I would love for browsers to go. I know that there's a long distance between here and there, and I deliberately intended for that to be provocative. And so I'll just put my 6 takeaways that I had throughout the talk up here again. I think that's my 45 minutes. I think we budgeted some time as well for Steve to be up here and just have a little bit more of an informal chat and Q&A. But I'll stop here. Thank you so much for listening.
Thank you so much, Arvind. And is Stephen here? Yes, great to meet you. All right, we're gonna do some Q&A now. We have a couple of stools here. So this is for folks obviously in the room. Have your questions ready. If you're watching on the stream, we're also taking questions in the speaker-series Slack channel. So thank you, Julie. So please, by all means. So let's start with the room. Does anyone in the room have any questions? All right, so we have a question.
Thanks a lot for the great talk. I've recently kind of been observing some users using privacy extensions. And the one thing that was interesting for me was the DuckDuckGo privacy essentials, where they kind of give people like a particular grade about a website based on I think based on lots of different factors, including the amount of third-party tracking, but also some of the first-party practices on that page. And noticed that people were interested in the grade, and that at least at some level of interpretation, but needed more information. And I was wondering if you thought, beyond just interpreting like deceptive ads on a page, whether there's a role for a browser to also interpret like the invisible tracking practices and provide recommendations and at some level of interpretation about what's going on and like threats that they might be facing as a result.
Yeah, I definitely would. Is this on? I definitely would like to see that happen. I will say I don't know how to make it happen. I know when I go to a page, I would love to get a readout of like, these parties are fingerprinting, this is the level of cookie syncing that's going on, this is the level of cookies that are being set or accessed. But I know most users aren't going to understand that. And so I've always wanted to see that information, but wasn't sure how to present it.
Thanks, Dave. I'll say a few words about that as well. I love the idea of a privacy grade. Actually, we've had many discussions over the years about doing that sort of thing with our data that we collect about the privacy behaviors on 1 million sites. The reason that we stopped short of that is because I think there are some ethical obligations for anybody who's doing that, which is to have perhaps a full-time person in place to handle complaints, any inaccuracies, and to fix them and so on. And we didn't have those resources. And so for any organization that is willing to devote those resources, I think that would be a great way to take advantage of all of the data that now exists about privacy practices out there. And we definitely like that DuckDuckGo is doing this. To your other question, could this be a way to give users more information? I think that could be really, really good for a subset of users. That's, as Steve said, it's not necessarily for everyone. If we look at Mozilla's Lightbeam, for example, I think it was a really cool tool. It is a really cool tool, but I think one of the limitations of that is that it's not connected to actionable steps that the user is taking. It's something totally separate and acts as a visualization. However, if that could be integrated into the user's decision-making flow, do I want to use website A or website B, for privacy to be one of the factors in that decision, this kind of tool that gives extra information could be very helpful in that context.
And what Arvind said actually makes me think of something else. So the DuckDuckGo extension is all client-side. And so you can do things like detect cookies and so on. But detecting some of these other techniques client-side is something that's difficult. And so when you think about if you want to detect fingerprinting, well, what if this script only fingerprints in certain conditions that aren't actually happening during the visit? So do we ship a list to the extension that's showing something that's not true? So those problems need to be thought through as well.
So we'll take one online after one more in the room. So D. Barron, you get one more in the room.
Sure. So one thing one of your suggestions that seems it seems more difficult to me than the way you framed it, is the progressive deprecation suggestion, where I think some of these forms of detection are sort of more practical when you don't have to think of it as an adversarial model. But once you're doing something where you're doing it on behalf of a significant percentage of the web's traffic, and the sites now have a huge incentive to avoid being detected, it's not clear to me that fingerprinting detection, tracking detection can be done to the level of reliability where essentially it's a security bug where we have to ship a security update if somebody finds a way around it. And I think for this to be meaningful, we need to get it into that state. Or else sort of the people who are on the cutting edge will just find ways to defeat our detection and appear not to be tracking, but still track. Do you think it's do you think it's actually practical to build tracking detection to this level of reliability that we could actually enforce that?
Yeah, that's a great question. Happy to say a few words about that. Obviously, it's not any kind of answer, but here are my thoughts on that. One is, I'm not sure I totally buy that this would have to be at the level of reliability that you need for, let's say, an anti-malware defense, because the consequences of the defense failing and letting a tracker through are not in the same category of an anti-malware defense failing and letting malware through on the user's computer. And I think most users understand this, and I think something that works, for example, 90% of the time would still be a huge improvement over the state of the art. And certainly there is a small fraction of users for whom the threat model is really a nation-state adversary. And for those users, I'm not proposing that this is a good approach. They are already turning to tools such as Tor and Tor browser, and I think that's a completely parallel kind of defense that is useful for those users. And the second point I want to make is that this kind of adversarial evasion is perhaps not as easy for third parties to do as a purely technical argument would lead us to believe. And one reason for that is that the FTC can and has stepped in when there is evasion of tracking protection techniques, such as Google's circumvention of third-party cookie blocking. And so, when I talk to people who are in the tracking space, they're very, very jittery about attempting this sort of thing. And so I'm not quite sure that the problem is as adversarial as we're formulating it. However, I do agree that there are many unknowns and there are some risks in attempting this path, certainly.
I can comment on some kind of the technical angle of it. I think when we started the project, I was really worried about trackers detecting OpenWPM and not doing things. And like what Arvind said to me was kind of, well, if they do that, we know we've won in a sense because now people care about us, right? But I think if Mozilla were to do something, trackers would try to detect it, right, and do something about it. I think we'd have a couple options. Like one, right now, a lot of the way we detect a lot of this stuff is client-side. If we had better support in the browser to detect things kind of silently in a way that the script on the page couldn't detect, that would be helpful. And then moving forward, if, say, crawlers are being detected and scripts, tracking scripts aren't doing certain techniques when they see it's a crawler, maybe there are ways we can collect that from users, maybe users who opt in and want to share certain information that helps us detect when a tracker is attempting to track them. So I think there are approaches to escalate technically as well, but ultimately, hopefully, it won't be as hard of a problem for the reasons Arvind said.
Okay, we're going to take one from online, and then we'll get back to the room. Yeah. So online, we have folks asking questions. So one question we got was, Arvind showed some obvious examples of behavior that most would object to, but in general, how do you define what intrusive tracking is or what dark patterns are in terms other than, I know it when I see it? For example, is first-party tracking always okay? Is third-party tracking always bad? Go for it.
Sure. So great question. I'm not saying that there is a perfect answer. However, there is low-hanging fruit in the sense that there are types of tracking that are going on where there is widespread consensus that this is vehemently against user expectations, and everyone who we've talked to, whether they're a privacy expert or they're a browser technologist, agrees that ideally these types of tracking should not happen. For example, exfiltration of usernames and sometimes passwords from these login forms. So I think this policy on unacceptable tracking does not have to be comprehensive in order to be effective. I think we can start with the low-hanging fruit and then work up from there. All of these are really getting us away from the baseline of saying this is not for the browser to do, this is for browser extensions, or this is for private browsing mode or whatever. I'm saying there are positive things that one can do by default to protect most users, even if it's not going to be and probably never will be a perfect solution.
This went by really quickly. I think that's a good sign. We have one more question in the room, and then we're going to wrap. So please.
Hi there, and thank you for a very nice talk. So I'm going to go back to your comments on the research, all of the research that was done on the sandboxing. I remember that. It was really exciting, and I actually recognized the Swedish researchers in that paper, too. And I think I know one of the reasons why it tapered off is that, and this also is true for today, a lot of the academic research goes back to when I did research too, is kind of isolated. These browsing engines are open source, but we almost never see any academic research going into and committing patches into the browser engines where they actually belong, where you can do the silent detection and not be hampered by restrictions on extensions, or you can't run the script first, or they can see your objects or something like that. And my question is, how do we fix that? How do we make sure that research groups such as yours go straight into the Firefox engine or WebKit or the Chromium engine, make the changes there, probably behind some compile time flags to get past code review so that people can turn it off in shipping products. Yeah. But that's how we eventually get it into shipping products. Yeah.
I have many suggestions, but I'll make one. And I think this is a thing that it's a small thing to do, can be done easily by teams such as Mozilla and would have a big effect, which is to participate in academic program committees. Program committees are the ways that we decide which papers are valuable and are going to be considered prestigious. And there's nobody there in those committees arguing for this kind of practical impact and patches and open source contributions. Often, even when the authors submit code, nobody who is reviewing the paper bothers to click on it and look at it and evaluate the code as part of evaluating the paper. So we're in a kind of a dire situation today. And I totally understand that it's kind of a thankless task. It's not something that you necessarily can put on your CV or get much personal gratification out of, because frankly, a paper reviewing is going to be it's time consuming. However, one conference per year can significantly move the needle.
I wish we had more time. I'm really happy that you're going to spend a little bit more time at Mozilla today. So Arvind, thank you so, so much. Stephen, thanks for joining up front. It was a pleasure. Thanks, everyone. Let's give Arvind some applause.
Thanks again.
Thanks. Insert browser music here.